Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about PN junction diode. This is a course called Electronic Devices and Circuits, and we are going to see about PN junction diode. What is a PN junction diode? And basically, what is a semiconductor? A semiconductor is a device. Semiconductor is a diode, or a semiconductor diode is a device which partially conducts. Okay, we have a conductor, insulator, and a semiconductor. Conductor is the thing where the electricity passes through, and the inductor is the material where the electricity does not conduct or electricity does not pass through. And the third one is the semiconductor, where the electricity passes through the material to a certain point. Okay, that is called a semiconductor. In this, we are going to see about PN junction diode. What is PN junction diode? Okay, it is a pure form of semiconductor where we have, it is a semiconductor device where we have a N-type and a P-type semiconductor. N-type is generally based on it is based on the impurities, majority carriers, whereas the P-type is based on minority carriers. Okay, fine. From this we can know that there is two types of semiconductors. One is intrinsic semiconductor and another one is called a extrinsic semiconductor. Where the intrinsic semiconductor is a pure form of semiconductor where we does not need any doping or an adding of impurities to that semiconductor. Okay, whereas the extrinsic semiconductor is the one where we add the extra impurities to the semiconductor and we process it for the further procedure. Okay, we can see that a pure silicon crystal or a germanium crystal is known as a intrinsic semiconductor, a pure form of germanium or a silicon. These two, are germanium and silicon, are called the pure form of semiconductor devices. Okay, it is since we know that pure form is of intrinsic form, whereas impure form, that is adding of impurities, is known as extrinsic semiconductor. Okay, so silicon and germanium crystals are known as intrinsic semiconductors. Okay, there are not enough free electrons and holes in the intrinsic semiconductor due to a usable current. Okay, as we are going to use a certain amount of current in it, so we'll have a minimum amount of electrons and a minimum amount of holes in it. Okay, to add those two, we'll be giving an external supply to it to recombine both the electrons and holes. Okay, the electric action, as I told you, the electric action of these can be modified by doping. Doping is called adding an impurity to a pure form of semiconductor is called doping. It is a procedure of adding an impurity. When a crystal has been doped, as I told you, it is called extrinsic semiconductor. We have two types, that is N-type and a P-type. N-type semiconductor will be having free electrons as majority carriers. Where P-type will have free holes as majority carriers. Will have electrons and holes where the recombination will be done and the further procedure will be taken care of. Okay, in a junction, if a junction is made by the joining P-type and an N-type semiconductor, we'll get a device called PN junction diode. Okay, the combination of P-type semiconductor and an N-type semiconductor combined together to form a device called PN junction diode. Okay, will allow the currents to pass through and will find the operation of how the PN junction will work. Okay, as I told you, this P-type material and an N-type material. P-type material will have holes, and an N-type material will have electrons. As I told you, N-type electrons will have holes as electrons as majority carriers, and P-type material will have electrons as a majority carriers. So while combining these two, we'll have p-type and an n-type combined together to get p-n junction diode. Okay, we'll have electrons and holes, they will get recombined each other, and we'll have a conduction recombination of electron and holes, so we'll form a p-n junction diode there. Okay, how these electrons and holes gets combined and how the recombination process is done and what is the purpose of these p-n junction diode. Okay, holes from p side diffuses into n side. Okay, p side will diffuses into n side, where we can recombine with free electrons. Okay, free electrons from n side diffused into p side, where they recombine with free holes. Holes from p side into n side will recombine free electrons. Okay, next the free electrons from n side and will be diffused into p side, they recombine free holes. Okay, p side electrons will move on to holes, and n side holes will be move on to p side, n side electrons will be move on to p side holes, p side holes will be move on to n side electrons. Okay, the diffusion of electrons and holes is due to the fact that large number of electrons are concentrated in one area and large number of holes are concentrated on the other area. As I told you already, large number of holes in the p side and large number of electrons in the n side will have they both will have large amount and they will get diffused. Okay, diffused or attracted each other. Okay, when these electrons and holes begins to diffuse across the junctions, that is Pn, the junction, they will collide each other and negative charges in the electrons cancels and the positive charges of the holes, and both will lose their charges. Okay, negative charges of electrons are negatively charged particles, right? They will get diffused, and the positively charged holes and positive charged holes will also get diffused, and they will have a low energy. Okay, next, the diffusion of holes and electrons in the electric current refers to as a recombination current. Okay, diffusion of holes and electrons in the electric circuit will refers to a recombination circuit when the supply is given to the p type and then n type. Okay, we'll have a supply, we'll giving a electrical supply external source, there we'll get an electrical energy over there. So by using that electrical energy, once electrical energy given, the electrons and holes will again get double the time, and it will again gets recombinated. Okay, the recombination process decay exponentially with both timing and distance from the junction. Okay, as the times and distance of the electrons and holes get recombinated, the recombination process takes place. The most of the recombination process occurs in the junction is made very near to the p and n, holes and electrons junction. Okay, that will form a we'll get a recombination of holes and electrons. Holes will be present in the p type and electrons will be present in the n type region. So that two get combines together and will form a depletion region. Okay, depletion region or a p-n junction. Okay. As I told you, this is the depletion region where the electron and holes get recombinated together. Right, this is the diffusion of p-n junction, depletion region, where we can find out. The electrical charged atoms are called ions. As I told you, when we give an external supply to it, we'll get the component will be electrically charged. Okay, they will not have any neutral. There is no, when supply is given, they will not have any neutrally charged particles. Okay, one is positively charged and one is negatively charged. After several collision occurs, the electrical field is great enough to ripple reset of the majority carriers away of the junction. As the supply is given, we will be having a large number of electrons and holes, in the p type and n type, it will get recombinated, they will get collide each other, and will get a holes in the p type and electrons in the n type. They form a depletion region. Okay, the region is produced immediately surrounding the junction that has no majority carriers, where electrons will be having a minor path, and holes will be also having a minor path. So they both combine together, they will not have a majority carriers. Okay, so the region which combines electrons and holes is called depletion region. Okay, the physical width of the depletion region depends on the doping level. How much the doping is induced into the PN junction diode, according to that this depletion region gets developed. Okay, this is the working of PN junction diodes, how the structure looks and the working of PN junction diode. Thank you.